Welcome to day 2 here at IPC APEX. As I said yesterday, it's definitely got a lot of new high-tech innovations at this show this week. And we're going to start off today with our first guest, who's Dennis Barbini, old friend from the industry. And Dennis, you've started a new company over here in the United States called Lasersem, a South Korean company, and you're the general manager for the United States. Tell us a little bit about the technology that you're introducing.
Thank you, Trevor, for having me here. It's a pleasure to be here at APEX, sharing our new technology. It's our first time exhibiting here in the U.S. Our technology is a selective laser process. We are looking at reflowing, let's say, odd form, fine-pitched, thermally sensitive components.
Right.
That we see a lot of growing areas of interest here in the industry with IoT and wearables and other type of niche type applications.
Okay. Laser soldering has been around for quite some time, but one of the issues with it has always been the fact that it's temperature, the burning issue you get on the laminates and that type of thing. What have you done to address that issue?
That's a very good question. We hear that all the time. What we're doing here is, what's unique to our technology is that we take a laser, an IR laser, and we put it through one of our beam shaping optical modules. In doing so, we disperse the energy over an area that is defined by the optics.
Right.
So whatever application it might be, we might be able to do a 4 millimeter by 4 millimeter square, or sometimes same area of a rectangle, or we can go all the way up to 80 millimeter by 80 millimeter.
Right.
So we have two different types of these optical modules, fixed design as well as variable. So we can adjust accordingly to the application. That uniformity of energy that's dispersed is greater than 95%. So we are very effective in delivering a certain amount of energy over a certain area very uniformly. So we can reflow solder without damaging any of the components, the board, or the solder itself.
So these modules essentially don't reduce the power getting to the joint, but they take a lot of the heat, or disperse a lot of the heat out of the situation.
Well, yeah, we're taking all the energy that's in that one spot and diffusing it over an area. Therefore, we are reducing the amount of energy concentrated in that area itself. Okay.
So so let's talk about the way that you actually do this. You have a couple of examples.
Yes, so we have a couple examples. First of all, setting up the process. Setting up the process is actually very simple. It's similar to, you use the same tools that you would use in a mass reflow profiling system. So you use your thermocouples, your recorder, you put your thermocouples where you need them to be.
Right.
And you try and optimize the process. In our case, the process goes from a 6-minute reflow process for forced convection down to about 5 to 10 seconds for the laser process. So it's a little bit different, but we're using the same tools. But we also add on an IR camera because this is an infrared laser.
Right.
So we can monitor the temperature as well using the camera. But other than that, you go through a stepwise process of optimizing it and getting your profile that you need.
So how easy is that to set up? I mean, is it just, how do you teach it?
Well, like you would in a typical user interface, we have a program where you plug in the steps that you want to have. When the board comes in, you're looking at a specific component, you optimize the process, it saves it as a file, and then you can recall it whenever you need to.
Right, okay. So, I mean, one of the beauties, obviously, of this system is going to be it's a much smaller footprint. Looking at some of the applications for it, you're able to do much smaller sensitive devices, as well as some large odd form devices.
Correct.
So a lot of companies maybe have a reflow oven there, which is supported by an old wave soldering system for doing the old odd forms. Are you saying that using this new laser system, you could pretty much do away with the wave soldering component, have this plus a few extras, for features for doing sensitive devices and hard to get to areas?
Well, I would say that we are not going to be replacing reflow or wave soldering anytime soon.
Right.
But I think that we have areas where we can certainly do the complex components that reflow and wave. They pour a lot of energy into the board, where we can just apply energy where it's needed to do a certain task.
Right.
So in that case, we are enabling end users to do things that they've never been able to do before.
Okay.
But we do, for very fine pitch, for thermosensitive, we can make sure that we address the issues of those components, optoelectronics, fine pitch. We've proven that this technology mitigates some warpage. We also have other devices that can eliminate it. We also have opportunities in odd form, like I mentioned before. So we have an array of different applications where we can selectively put the energy in, but outside of that area is going to be completely cold.
Right, because
less than
the
100
process
degrees.
is so fast, it doesn't allow enough time for the thermal transfer to go down into the board.
There's that as well, but because we're only shining the energy in one area, there's no bleed over because it's very fast, as you mentioned, and it's also, we're only optimizing the process to get the energy into the solder joint to form a properly coalesced solder joint, and then we're done. So energy doesn't flow into or around that component.
So you avoid oxidation into the solder joint.
Yes, we don't use nitrogen, and we use a fraction of the electric costs that you would do for a mass reflow process.
Right. Have you got any of these systems in the field at this point?
Yes, we do. We have systems over in Asia, in China, Taiwan, Korea, Japan. So our coverage is out in the Far East at this point, but we are actively doing evaluations here in the U.S. So we're welcoming the opportunities as we speak.
Great. Well, it sounds a superb new technology, Dennis, and we wish you every success with it.
Thank you very much.
And thank you for introducing it to us today.